Okay, this is lesson 1.8, transformations, putting it all together. If some of the lessons have been a little spotty up until now, hopefully this is the one that brings everything together. Okay. Basically, you can do all of these transformations at once if you can pick out the A, K, C, and D, the vertical and horizontal stretch and compression factor, and the translations left, right, up, down from an equation. If you can do that, you can do most of what we need to be able to do here. So if we had an original point, and we wanted to transform it using any of the transformations we've gone over, we could do it transformed point by taking the original x and dividing it by k and adding d, taking the original y, multiplying by a, and adding c. Remember, k and d act on x, horizontal stretch and compression, horizontal translation, acting on x, horizontal acts on x, x is horizontal. Y, vertical stretch or compression, that's what a is, multiplier on y, and then adding c, vertical translation. This notation here, x over k plus d, ay plus c, is called mapping notation. It's how you take points off of a parent and you transform it to get a transformed point. And if you can do multiple points on an original parent function, you can get a brand new graph. So that table we've kind of been looking at in pieces throughout the last few lessons. Here it is in all its glory, summarized completely. We're not going to spend too much time looking over it, but let's take a look at a couple equations and see if we can pick out the A, K, C, and D. So any function that has had transformations, if we can write it following this structure, you can easily pick out A, K, C, and D. Because A will be in front of the function, K will be factored out inside the function, D will be adding or subtracting on x, and C will be adding or subtracting outside the function. So let's take a look at some transform functions and see if we can put the letters to the numbers and then change the numbers into actual transformations in words. Let's take a look. There's a typo here. There should not be a squared. So we're going to ignore that. It should not be a squared. We've got 2/3 f bracket negative 2x plus 6 and nothing outside here. So right off the bat, we see that there's a multiplier in front of f. That's a. The multiplier in front of f is a. So if we create a little summary chart over here, a is 2/3. And if we can take an a value of 2/3 and translate it into words, we'll know what type of transformation that is. Inside here, we have something added to x and then multiplied by x, but we don't have it in this form of factor here. So if that happens, if you don't have a multiplier with a bracket around the x, you have to common factor. So I'm going to rewrite this, 2/3f. We're going to common factor the negative 2, and that would leave us with x minus 3. Because if you distribute the negative 2 back in, you get negative 2x, and negative 2 times negative 3 is positive 6. So we just common factored. And now we can start to follow a little bit more patterning. Inside the multiplier, in front of the bracket, that's your k. So k is negative 2. And adding or subtracting to x is d. And remember, d has opposite signs, so be careful here. X minus d, so d must be 3, because x minus 3. And then plus c, outside at the end here, plus c, there's nothing there, so c is 0. There's your A, K, C, and D. So now we want to try to translate those letters into transformations or words. Let's start with A. A describes vertical stretch or compression. Since this A value is less than 1, it's a vertical compression. And the factor we're going to always describe by is a factor bigger than 1. A factor of If a is not a number bigger than 1, to write it as a factor, you flip it, 3 over 2. So this is saying take your y's and divide them by 3 over 2, which is the same as saying take your y's and multiply them by 2 over 3. Okay, that's why factor 3 over 2, bigger than 1, flipped it. K. K is horizontal. K is negative. So we actually have a horizontal reflection. And a horizontal. K is bigger than 1. If we ignore the sign, the magnitude of K is bigger than 1.
Ms. French, please dial 187.
And since K is bigger than 1, that's a horizontal compression. By a factor of 2. D is 3. D is your shift left, right. So it's a horizontal shift, 3 right. And C is 0, so there's no vertical shift. So there's our 4 transformations. Let's try it again with B. B is written in kind of a weird order here. I'm going to rewrite it in an order that makes a little bit more sense. Negative 3. I'm going to write that at the end. Negative square root, keep. And we've got negative 2x minus 8. Again, we don't have that bracket, so we're going to common factor that negative 2. And we get x plus 4. Now let's see if we can pick out our A, K, C, and D. A, K, C, D. A is the multiplier outside the function, in front of the function. The function's the square root function. The square root function has a multiplier, negative 1. The multiplier acting inside the function on the x, that's negative 2, that's K. D is the number being added or subtracted from x. X minus D, so that means that D is negative 4. And C is the number being added or subtracted outside the function. It was in front here, it's a little tricky to tell, but if you move it to the end, you can kind of see it a little bit better. C is negative 3. There's your A, K, C, and D. What I'm going to ask you to do is to take the A, K, C, and D and translate it into words. And you can check the solutions on the course website to see if you did it correctly. All right, let's flip the page. The parent function is the square root of x. Graph the transformed function. So, what we're going to do here is we're going to use mapping notation to graph it. So, I'm going to start with some key points on the parent function. Well, what are the x's and y's? What are the original x's and y's? Well, 0, 0 is an original, 1, 1. 4, 2 is a nice one, 9, 3, 16 and 4, 25 and 5. Those are some really nice points. So 0, 0, 1, 1, 4, 2, 9, 3, 16, 4, and 25, 5. 5 points is usually enough. We got 6 here. We'll just stick with the 6. And then we're going to transform it using mapping notation. Well, what's mapping notation? Mapping notation says take your original x's, divide by k, add d. Take your original y's, multiply by a, add c. So we need to figure out what those are. And if we can figure out what a, k, c, and d are, we can just do the multiplication and addition. So let's look at our equation. Here's our transformed function. Pretty good so far. There's an a that's pretty clear. There's a c that's pretty clear. There's no bracket around the x, so that means we probably have to do a little bit of common factoring. So let's do that. Always watch for that common factor. Plus 4. And now we can tell the k and d negative 4. K is negative 2. A is 2. C is negative 10. And there we go. From the equation, we can pick out the A, K, C, and D. So to find the new points, the transformed points, all we need to do is take our original x's and divide by k. Well, k is negative 2. So we need to take our x's and divide by negative 2. And then we need to add d. Well, what's d? d is negative 4. Add negative 4 is like subtracting 4. To find our new y's, we take our a, which is 2. We multiply it by y. And we add c. c is negative 10. So we have an original table, and if we do these operations to all the x's and these operations to all the y's, we'll get a new table. So I'm going to rewrite that. X, we're going to divide it by negative 2, and we're going to subtract 4. A's, ay, 2 times y, minus 10. We're going to take our y's, multiply by 2, and add 10. This one seems a little bit easier. I'm going to do the y's first. 0 times 2 is 0, minus 10 is negative 10. That's our first one. We took our 0, multiplied by 2, and subtracted 10. 1 times 2 is 2, subtract 10 is negative 8. These are linear, so once you see the pattern, you can probably fill in the rest. I'll keep doing a couple more. 2 times 2 is 4, subtract 10 is negative 6. You can kind of see the pattern. So going up, the numbers are increasing by 2 each time, so we'd expect maybe negative 4, negative 2, and 0. And if we double check, we'll do 5. 5 times 2 is 10. 10 minus 10 is 0. Right on. So there's our new y's. And if we know the x's, then we can plot some points and we get a new graph. X is divided by negative 2. 0 divided by negative 2 is 0. Subtract 4 is negative 4. We got our first point. Negative 4, negative 10. Negative, on our scale, negative 5, so negative 4, and all the way down to negative 10. And we've got a point. Yay! Let's get a couple more. 1 divided by negative 2 is negative 1/2. Subtract 4 is negative 4 1/2. Negative 4 1/2, negative 8 is our next point. Negative 4 1/2, negative 8. And our next point, 4 divided by negative 2 is negative 2. Subtract 4 is negative 6. Negative 6 is our next point. And if we keep, oh, that was wrong. And if we keep following through, we get the rest of the points to complete our graph. And I'm not going to do the math. I'm just going to write the answers down for the last ones. And if we graph these, negative 8 1/2, negative 4, that'd be 9, 8 1/2, negative 4. And negative 12, negative 2 would be here. And negative 16 1/2 and 0 would be there. And if we connect and extend, we get our transformed absolute value graph, g of x. We're going to do definitely some more practice with that in class, but that's using mapping notation to transform a parent function. Equations of transformed functions. So you don't know what transformations have happened, but we're going to write an equation from the parent. And to do this, what we do first is we identify, I'll write a couple steps, identify the parent. So look at the shape and identify the parent. This one is V shape, so that means it's the absolute value. So we're going to use f of x equals the absolute value of x. And then step 2, identify the translations. And there's always a key point that you can look at to identify the translations. And when you use the absolute value or the parabola, you're looking at like the vertex or the turning point. And that turning point in this case is negative 2, 1. So that negative 2, 1 tells you that it's a shift left 2, up 1. So we can identify a bunch of the transformations already. And step 3 is choose A or K. So we're not going to use A and K because we have to make the question much more complicated. But A could take care of any sort of stretch or compression as we saw in the previous lesson, whether it's horizontal or vertical. Alternatively, you could choose K. It's easiest usually just to choose A. So let's do that. We're going to write a function. an f of x that has an a, absolute value, x, a minus d, and a plus c. So we can fill in a couple already. Left 2 means that d is negative 2. And up 1 means that c is 1. So we can fill those in. F of x equals a. X minus negative 2 would be plus 2, plus 1. And your fourth step is plug a point in for x and y, solve for a. So pick a point off the graph, plug it in, and solve for a. 0, negative 7 is a good point. So I'm going to plug in 0, negative 7. Negative 7. A, absolute value of 0 plus 2, absolute value plus 1. And now we're just solving. Subtract 1 from both sides, we end up with negative 8. 0 plus 2 is 2, the absolute value of 2 is 2. 2 times a. Divide both sides by 2. You get a is equal to negative 4. And last step, rewrite the equation. With a. Therefore, we got f of x equals negative 4, absolute value of x plus 2 plus 1. And, oh, cut that off, sorry. Rewrite the equation with a. A was negative 4, which if we look at the graph, vertical reflection, upside down, good, and a vertical stretch, much narrower than we would expect to follow the 1-to-1 ratio. So there's our equation. Two more examples. The graph g of x equals x squared is horizontally stretched by a factor of 2, reflected in the y-axis, stretched vertically by a factor of 3, reflected in the x-axis, translated to the right 5 units, and down 3 units. Write the equation of the transform function. To do that, what we need to do is we need to write what the function would look like with all those transformations in it. We'll start by just writing it with a, k, c, and d in it, and then we'll fill in a, k, c, and d if we can. So our function is g of x. A would go in front of our function. Our function is the quadratic. Inside the quadratic, we'd have k, potentially, an x minus a d, potentially, and a plus c on the outside. And now we read through the question and see what we can pick out. The graph of g of x is horizontally stretched by a factor of 2. Horizontally means k. Stretched means that number's between 0 and 1. And by a factor of 2 means that k is 1 over 2, reciprocal. Reflected in the y-axis, reflected over the y-axis means that we're reflecting horizontally. So that means that that k is negative. K is negative. So our k is negative 1/2. Stretched vertically by a factor of 3. Vertical stretch is a by a factor of 3 because it's stretched, means a is 3. Reflected in the x-axis means a is negative. So that means a is negative 3. Translated to the right 5 units, left right is d, and to the right 5 means d is 5. And down 3, down, up, down is c, down 3, c is negative 3. And now we just have to fill in our equation. You can write this format for any function. A multiplies in front of the function x squared. K and d act on x inside the function squared. C adds to the function outside the function. Once you can write this format for all the parents, and you can pick out a, k, c, and d, it's pretty easy to write the equation because now we're just substituting. A is negative 3. K is negative 1/2. D is 5. c is negative 3. And there's our equation. Last example. A point, negative 2, 8, on a function is transformed according to these rules. What are the coordinates of the transformed point? This is very similar to the example we did on the previous page, example 2. But instead of transforming a whole function, we're just doing one point. So original. There's an x and a y. And it's negative 2, 8. And then we have to create a mapping notation, which is x over k plus d and ay plus c. So from an equation, we need to be able to pick out a, k, c, and d. And we want to come up with the coordinates of a transformed point. So let's see if we can do that. Let's pick it out. Need some more space here. Our function is g of x. G of x equals negative 1/2 times f. F is our function. Negative 2x plus 10, not common factors, so I'm going to common factor it down here. Minus 5, minus 6. And now let's see if we can pick out a, k, c, and d. A is in front. K is inside the function multiplying. D is adding or subtracting on x. C is adding or subtracting outside the function. So we're going to take our x's and we're going to divide by negative 2. We're going to add d, which is opposite sign, 5. We're going to take our y's and we're going to multiply by negative 1/2, a, and we're going to add c. C is negative 6. So here's our rules. So to find our transformed point, we're going to use our mapping notation. To find our new x, we're going to call it x transformed. We're going to take our negative 2, our original x, divide it by negative 2, and add 5. Which is, negative 2 divided by negative 2 is 1, plus 5 is 6. The x of our transformed is 6. To find y of our transformed, we're going to take our y, which is 8, and we're going to multiply it by negative 1/2, and we're going to subtract 6. Negative 1/2 times 8 is negative 4, subtract 6 is negative 10. Our transformed y is negative 10. So our new point is 6, negative 10. All of these questions are essentially the same thing. You need to be able to find a, k, c, and d from a description, from an equation, and use a, k, c, and d to write the mapping notation to find transformed points. That's the thing we're going to practice for 2 days now in class. Thanks for watching. That's our last lesson of the unit. We'll do a bunch of practice in class to get you ready for your test coming up. Thanks for watching, and I'll see you next time.